So let's design something together. It's going to be a solar dehydrator. Now I have a solar dehydrator now. And it's your usual cabinet with a thing that comes out the side, pointing towards the sun. And it's a flat black thing with a bunch of glass over it so that the incoming air heats up and dries out where it's drier, passes by the food and dries it out. Now, it's great. It works fine. Right now I have a snake in there that I put in there to dry out. And all the flesh was eaten off of it or turned into powder. So it's just a snake skeleton now, which is kind of cool. And I think I need to take that and take some super glue and glue all the joints together. So I have a snake sculpture. That'd be really cool. But there's other things you want to dry out other than weird stuff like rattlesnakes. And that is food. That's probably the number one. That's the easiest way to preserve food. It uses less energy than canning and other methods. Often people dry stuff just in the sun, but I want to do it better. And I actually don't want the sun to hit it. Now in my current one, the sun doesn't hit the food. But I don't want the sun I don't want the food to be touched by the sun, because that might sterilize it, but it might help things grow on it. I don't know. I just don't like it. What I'm picturing is a room-sized solar dehydrator that you can load up trays of food, lots and lots of them, and it can serve a whole community. I mean, every day it's cranking out huge amounts of dried food. And this could be done farther down in another climate, and it could be done up here so that we can dry foods and ship them easier to other places. It makes a better product. It's a more stable product. It doesn't rot, and it doesn't really affect it nutritionally. So here's how I want to do it. I don't want to collect the sun the way that has been done, the way I do it now. I want to instead use what's called an evacuated tube solar hot water heater to heat up water that then goes into the building. The heater will be below the building. It will be built on slope, right? That water will automatically flow up into the building, heating up the thermal mass in there. And I don't know, there's several things I don't know. I'm not an engineer, there's a limit to how hot you want it to get. You don't want to cook the food, although I don't know that would hurt anything. It depends on what it is. But, sorry. All right, there's a bunch of shit to figure out. It's a really simple thing. We want to measure the water temperature coming in, measure the room temperature, measure the humidity in the room. I want the airflow that's coming in, because in the other one, the airflow comes in through the heater. We're not doing that. I want the airflow to actually come in through the ground. And here, the reason you want cold air to come in is because cold air holds less moisture. So the colder the incoming air, the drier it will be. Heating it up then, the difference in the two temperatures is the potential drying impact that it can have. And then there's the other question of how long do you have the air stay in there for? Does it just pass through? Probably. But it actually has a certain carrying capacity for moisture. So, you could imagine a fan doing it, but the air will naturally be heating up and go out the top. And so I don't like moving parts. So I don't think a fan would be necessary or even useful. Now, do we really need to have the air be colder? I would recommend it. And there's two kinds of ways to get cold air. One is it could come from piping that goes through the ground, right? because the ground is at a lower temperature. But at night, the question is, in this climate, because the design is going to be climate dependent, and you'll have to adjust it for your climate. I live in Coppin Climate Zone CWA/CWB, a really nice climate to live in. But it means it doesn't get really super cold. If you live in a place where it's winter and sunny, this thing would work great. If it's really cold out, you got cold, dry air. That's why your lips dry out in some cold climates, because it's always being exposed to really dry air. So anyway, the idea of using these evacuated tube solar hot water heaters is that they'll work all day long. They will also heat up a thermal mass within the building, and they're going to be doing that every single day. And so even at nighttime, that night air would come in even colder and drier, and you'd be heating it up, and so it would continue working at night, which is really great because the one I have now stops working when there isn't sun. And even shade can slow it down a lot, and then of course nighttime it doesn't work at all. So, and you want to dry that food out as soon as you can. You want to cut it up, have a whole team that their job, for not for all day, because I don't think anybody should be doing one job all day. I'm against that kind of. It seems boring, but for you could set up half-day shifts of a bunch of stuff, and maybe people do 2 different shifts, and that's their job, and that gives them more mental variety, and they could even be trained on as many jobs as possible. Cross-training people should be absolutely critical for the health of the system, and then they can be signing up for different types of shifts, and we can also measure their effectiveness in a shift, and that can impact who we prefer for various shifts of various types of work. There can be a forge for foraging, there can be plant reproduction, there can be geek tasks of all kinds on the computer, there can be chopping wood, gardening, trail maintenance, construction, all sorts of stuff. And I don't know, this is not a hard and fast rule that people should only work part-time in any given job, but that would be really cool for the flexibility of labor and for the happiness of people if they have the ability to move from one job to another. Sorry, we're not designing labor systems here. We're supposed to be talking about engineering and dehydrator. Anyway, the evacuated tube solar hot water heater is super efficient. For those of you who don't understand it, you should be able to explain this really well to people because it is the best way to use solar power. Way better than photovoltaic. Solar panels are way too complex. There's black tubes, and the sun hits the black tube. Outside that, there's a glass tube. Between the two, there's a vacuum. Zero heat can pass through a vacuum. So you got all this solar radiation coming in. The tubes are filled with water. The water heats up, loses no heating due to the vacuum, and rises naturally into a big silver thermos thing. Then it's available. From the big silver thermos thing, the hottest of that water would then flow up into the building, which would be super insulated, and it would flow into a thermal mass. That thermal mass would just keep heating up. Now, building just building the first one would be fantastic. And it could be made with cob or adobe. It could have an insulating roof. On the top, it would have vents that air can go out of, and you should be able to adjust those. They could just be metal sliding windows with screens in them because you don't want any bugs to come in, and you want this whole thing to be rat-proof and all that. So there'd be a door on it, and you would open that door up, and you would load it up, and then you would actually, have external. You want to open that and close that door as little as possible, probably. So you would want external readouts of what your humidity and temperature are inside, and perhaps measure the temperature at the bottom and the top. And then you could be drying food at a much more rapid rate than any other system I can think of. Now, there is something that's better than drying food, and that's freeze drying food. But that uses a bunch of electricity, They're very expensive machines. We don't know how to make them, right? Not that we know how to make a evacuated tube solar hot water heater either, but they're pervasively available and they're very cheap, and they would just work automatically forever. And so I'm not going to go with freeze drying. I know that's slightly better. It's significantly better for preservation, but also not everything has to be dried out completely. I mean, like sliced mangoes, moderately dried, make an amazingly great snack. Or you could keep drying it, and then you could powder them. Actually, that might use more space. It depends on how you pack them. But for shipping, and it would, yeah. So there are a bunch of options here. You could even dry meat. You know, they sell dried meat, actually, and beef jerky is dried meat. So it's not that radical of a concept. I'm imagining the first one would just be a small room, and you could also dry clothing in it. So, I mean, the thing about it, it's an experimental thing, and I suppose you could get an engineer to calculate how many BTUs of heat are going in, and I mean, do some smart thinking about it. But really, it's just a matter of building it. So, you know, make a small cob room, place it correctly so that the sun is going to be hitting that heater all day long, and then have your measurement devices, particularly on the first one. Once you get it working, when you have your design down, if it works great, you don't have to include devices to measure stuff on all the rest of them. What else? It's pretty basic, and they have screens, and some screens would be metal and some wouldn't be. Like anything that's really acidic food, like tomatoes, for example, you probably wouldn't want to put on a metal screen, and you have to have a way to clean those screens, although they should stay pretty clean. Because if we got no bugs, if we're drying the hell out of them constantly, we're not going to get a lot of stuff growing on them. So that would work out pretty well. You could have the venting of it, the excess air, also go upslope into something else. And you would be able to measure that humidity as well. I don't know if that's beneficial or not. I don't know if you get any weird smells because all this air is now filled with, the liquid that came out of the fruits and stuff. But we just find that out, I guess. It'd be something to think about. Potentially that's a crowdfunding project to design the first one and test it so that other people could, for free, copy the design of it and implement it with some adjustments for their particular climate. I think in general, it would work really well in all climates. In particular, in humid climates, you would want to make sure you're using that night air really well. You could also plan ahead for having a system to have a fire system outside of it that you could heat up air with that would then go in. That would be supplementary, but I would see that as failure because all of a sudden you're looking at using wood. We don't want to use wood. We don't want to use any additional energy, just solar energy. So you could just kind of know in your design that you should reserve a spot in case you need to have a fire assist. But I believe you just won't have the problem. Those evacuated tube solar hot water heaters will boil water. That's how good they are. So if this existed, one or two of them would be enough for a town, really, because people would be bringing in their fruits and veggies at different times. In town, near where I live, there's actually a mill, and people can bring grains to the mill, and then they have an electric or gas, I don't know what it is, it's electric, mill that they can have their grains milled, and now they've got fresh flour or corn or whatever it is. Because as soon as you mill it, its lifespan goes down. So you want to keep it in grain form for as long as you can. And so I imagine a solar dehydrator would work the same way in a community setting where people take their stuff to it it's checked in, right? And then it's dried out and they come pick it up. And right now in my solar dehydrator, it can take 2 to 3 days to dry some kinds of stuff out, like bananas and things like that. And I think this one would work way faster. And we would find that out because we could, at the same time, put one in my old style dehydrator and then put one in the new one, and we could actually measure. I don't know if there's a device, like you can point it at something or measure humidity of something, but we can also just do it visually, right? You know when something's dried out or not. So I like the idea, and I have a whole book just on solar dehydration of food, or food dehydration. I don't know if it's solar. I mean, a lot of people buy these little electric ones. I just don't like small scale. And the thing is, it benefits the producer of the food or product a heck of a lot if they're able to, God damn it, forgot something again. God, that's annoying. I'll be fine. Fuck it. Anyway, it benefits the producer if they can immediately harvest and then dry. Because even transporting it somewhere else to be dehydrated, it's going to cost more unless you dehydrate it right there on site. And so I would actually want to go into these other climates near here and work out with somebody else to do this same thing, or perhaps even buy a piece of property and install these dehydrators and then buy the products locally. So we don't even raise the products, but we raise the value of that product by dehydrating it. That's a really bright idea. And we would be the first consumers of it. Also, for survival, that turns something that's going to rot into something that's not going to rot. So it makes survival food. It makes your food last longer. And we want to be storing a lot of food as a society because we don't want to die when there's a interruption in the food supply. So that's it. That's the basic idea. Cost on it, a small adobe room would cost something. The air that goes out of it could actually go into a chicken brooder, because I also want to build a solar heated chicken brooder, and that could be uphill from there. In other words, I don't want to waste that hot air because it's still going to be hot when it leaves, right? It's going to be hot and wet. Although I don't want too much humidity with the chicks, little baby chickens. And in theory, it would be fairly humid air. I mean, that's the goal, right? I don't know, but there's no point in wasting any heat. Heat is a valuable resource. So anyway, that's the basic idea. Cost, adobe, we'll go with adobe, not cob. Concrete foundation. How to move the heat into the thermal mass. You could just put it in the flooring with PEX tubing. I've never trusted PEX tubing and I can't make it, so that bothers me. But alternately, it could also, that water could go into the floor, into, it could go through channels in the floor and then like have a maze of brick or something that flows through, and then it comes back out and it's lost as much heat as it can lose, and it flows back into the hot water heater. Let's see, water goes in. It doesn't matter. I mean, you could go into a barrel in there with copper tubing that coils around and heats up that water in that barrel to the highest degree possible. Another idea would be radiators, like car radiators. That's a possibility. I mean, it's a closed system, right? It's not going to touch the food. And radiators are made to radiate. That's the point of them. You could use car ones or other ones, but I mean, that's something you could get at a junkyard, right? And they're made to radiate. So that'd be a great reuse. And so it could just be that this hot water goes into a set of radiators. And for testing, because there's issues I don't know about here, like how efficient is it? And so the first one, we'd want to measure the water temperature that comes in. We would want to measure it as it comes out. The reason I mentioned thermal mass before, though, was that I want to heat up something that doesn't cool down as quickly at night. And I know that some people have used sand and salt and other stuff as batteries, thermal batteries. And that's really what we're trying to create, is a thermal battery. But we're not really trying to retain heat that much. In fact, it's okay if by morning that thing is cold. And the danger of getting it too hot and cooking the food is pretty minimal. There is actually an ideal temperature probably for the air to get to, and it's in my book. So I don't know, there's some minor engineering, but I think pretty much just buying the hot water heater, because it's mobile, you know. I mean, with 4 strong dudes, or chicks, whatever. Sorry, I'm intermittently sexist by accident. Doesn't really mean anything, though. Don't get your panties in a wad. I don't even have enough stuff right now to dry out, but I could also buy things in the market, especially things in season. For example, a dried tomato is worth a lot more than a not dried tomato. And, we could even be making avocado oil. I'd like to make avocado oil as well, because there's avocados around here pretty cheap at times, and I think they're going to get cheaper, relatively speaking. And if we made that into oil, and then we put these tomatoes into that, I immediately think of olive oil. But what would happen if we put in avocado oil? I don't know if that's smart or not. And I don't know the value of avocado oil. But I know that it's gone up a lot. And I don't know how its value compares with olive oil. Sorry, olive oil has gone up in price quite a bit. I don't know about avocado oil. I think that's the whole idea. If you have other ideas, feel free to let me know. I want to avoid doing it in a haphazard way, I guess. I don't want to fuck it up, because, everything has a cost, even if it's not very big cost. Come on. Oh, no, you fuck. God damn it. Fucking phones. Yeah. Give me your ideas. I guess I should sketch this up. I actually did download SketchUp, but really it's just a box. And I don't know what the roof should be made of. It could be, wow, it'd be really fancy if the outlet of the air kept the air in there long enough, because we don't want to cool down. And that window could actually be, again, I want to avoid moving parts, but what if that was controlled by temperature and humidity? And it said, if the temperature is too high, open the window more or turn on a fan and start venting it. Or if the humidity has gotten to a very high level where we know that there's going to be more dry air available, so why are we slowing it down? Like, especially if we have access to cold air coming in through tubes, which we want to make sure nothing lives in those tubes, right? We don't want to be pumping contaminated air into it. We wouldn't have to pump it. It would just magically flow in, right? Because actually the air could go through the thermal mass and be automatically heated up. In fact, that's how it would heat up. How you do that? They have these things called heat exchangers. I need to read about heat exchangers, because I want to move heat from one thing to another. In this case, I want to move it from water into air. And so if the incoming drier air, which could be just out here air, or through tubes in the ground, or just night air at night, and we want to compare night air temperatures with ground temperatures, and it could even be set up so that I mean, again, I don't want to make it complicated, but it could be set up so that it could switch which the incoming air was, whichever one's colder, right? I mean, if you want to get really fancy, you could have it go through a refrigerated system before it got to being heated up, and then water would come out of it. But then you got water, and I don't want that. So I don't really, I want to mess with that. I want this thing to be as simple as possible. So all these extras, all the extra electronics or moving parts, every one of them is a threat to the success of the object, because when one fails, not if it fails, but when it fails, then it breaks the whole object. So we want to keep it as simple as possible. But right now people do stuff like they dry corn on their roof, which is fine, it works. But I don't know, I think we can do it faster and better. And we could also harvest that corn off of the cob. They just do it on the cob, right? But we could harvest it, cutting it off when it's fresh, and then drying those kernels out. That'd be cool. I don't know, there are a lot of options. Yeah.